Which of these gallbladders came from bears? Which are from pigs? You may think you know, but would your hunch be considered proof in a court of law? No one can positively identify the gallbladder of a bear by sight, smell, or taste. At least not in a manner that will support the arrest and conviction of suspects illegally trading in bear gallbladders. The commercial sale of bear gallbladders for use as traditional Asian medicine poses a threat to bear populations worldwide. As bear populations in Asia decrease, users of bear gallbladders as medicine are looking to the bears of North America, Russia, and even South America to supply their needs. With the price of a single bear gallbladder in Asia averaging more than $1,000, bears around the world are becoming far more valuable dead than alive. One of the main obstacles to enforcing regional, national, and international laws and treaties regulating the sale of bear gallbladders is distinguishing the gallbladder of a bear from that of a common species such as a pig, cow, or water buffalo. Such identification is impossible without laboratory testing. However, there is a simple test which can be used by anyone with a little training to prove whether a gallbladder found on the commercial market is in fact from a bear. This is the National Fish and Wildlife Forensics Laboratory, located in the western United States. Scientists and technicians here analyze evidence from wildlife law enforcement cases around the world. Their job is not only to identify evidence by species, but also to determine cause of death and, when possible, to connect wildlife remains with a suspect or crime scene. The lab's warehouse is filled with contraband ranging from caiman purses to polar bear rugs to tiger bone liqueurs. In the lab's serology department, a drop of blood may provide the necessary evidence to send a wildlife poacher to jail. In the morphology unit, hair and feathers provide clues that make or break cases. And in criminalistics, various chemical methods are used to positively identify evidence, such as elephant ivory, rhinoceros horn, and bear gallbladder. One of the methods used to identify bear gallbladders is called thin layer chromatography, or TLC. Now, don't let the name put you off. The process is easy to follow and does not require the laboratory equipment nor scientific expertise employed in elaborate tests like the one you see here. You will need only a few pieces of simple equipment, some of which you may already have in your possession, and several common chemicals. If you had a chemistry class in school, you probably will feel quite comfortable with this procedure. Bile is a fluid manufactured by the liver of all mammals, including humans. It is stored in the gallbladder and released into the small intestine to assist the body in absorbing fats and cholesterol. The bile found in a bear's gallbladder contains medicine coveted for use in traditional Asian medicines as a treatment for serious diseases of the liver, gallbladder, and heart. Bile ranges in color from golden yellow to olive green to dark brown. It tastes very bitter. There are approximately 112 different bile acids, but when identifying the gallbladder of a bear, only 3 bile acids are of importance. The bear family, known as Ursidae, is distinguished by the presence of the bile acids tauroursodeoxycholic, tauroquinodeoxycholic, and taurocholic. These are referred to by chemists as taurourso, tauroquino, and taurocholic acids. While other mammals have trace amounts of these acids in their gallbladders, bears are the only animals with significant concentrations of them. Of 600 species tested for bile composition, only members of the bear family showed this unique profile made up of these three bile acids. The most important of these acids is taurourso, which gets its name from the Ursidae. Ursodeoxycholic acid has been clinically proven via Western medical standards to dissolve gallstones without surgery, and a synthesized version of this bile acid is widely used for that purpose by Western physicians. Synthesized urso, which is made from cow bile, has also shown promise in laboratory tests as a treatment for certain liver diseases and other important applications. You may have to order some of the equipment necessary to conduct this test from a scientific supplies catalog. Along with a variety of glass vials and flasks, you will also need a hairdryer, a hot plate with a flat surface or an oven, a small sprayer with a protective hood, a glass developing tank, and silica gel thin layer chromatography plates, also known as TLC plates. TLC plates are simply thin plastic or glass sheets covered with a chalky white coating of silica gel, on which the presence or absence of bear bile will be mapped. Safety glasses and a long-sleeved lab coat are also recommended for your personal protection when working with certain caustic chemicals. After the initial costs of buying the equipment and chemicals necessary for setting up this procedure, each test will be quite inexpensive, and as many as 15 bile samples can be tested per TLC plate. A good way to understand how thin layer chromatography works is to run a test using common food coloring. Spots of 3 color samples are placed on a TLC plate. To concentrate each sample, spotting should be repeated 2 or 3 times at each location, then dried under a hairdryer between spottings. The TLC plate is then placed in a solvent solution contained in a development tank, which in this case is a peanut butter jar. The only requirements of a development tank are that it have enough space to allow the TLC plate to stand upright and a lid with a tight seal to prevent evaporation of the solvent. Watch the solvent soak its way up the plate. As it climbs, the component colors of the food dye will separate. Once the test is complete, you can see that the food dyes all had a base of blue, but each had a different colored dye as a secondary component. TLC makes the components of bear bile acids separate in a similar fashion. When bile acids come from a bear, they leave a unique profile on the TLC plate that is significantly different than that produced from the bile of other species. There are several solutions, called standards, which must be prepared before conducting your test to detect the presence of bear bile. If you have bile from the gallbladder of a known bear, this can serve as your standard of comparison. If you do not have a known bear gallbladder in your possession, you will have to make up standards for each of the 3 signature bile acids found in bear gallbladders. These standards must be pure and can be purchased from a chemical supply company. The TLC profiles of these standards will be compared to the profiles of the bile samples you suspect may have come from bears. If they match, then you probably have bear bile in your possession.
I'm preparing a 1 milligram per mil solution of torourso deoxycholic acid, one of the primary bile acids for bear bile.
If the sample of unknown bile you wish to test comes from a dried gallbladder, then you will place 1 milligram of bile crystals into a small glass test tube. To guarantee accurate results, it is important to cleanse utensils between weighing different samples. If you are testing liquid bile taken from a fresh or frozen gallbladder, you will place 100 microliters of the bile liquid into a test tube. You will then add 1 milliliter of methanol to each tube, mixing gently for 5 to 8 minutes. A sonicator emits a subtle vibration that will thoroughly mix the solution and is standard equipment in many chemistry labs. If you do not have a sonicator, you may shake the solution by hand, but make sure to tightly cap the test tube before doing so. Mixing a fresh batch of developing solvent before each test will ensure that your results are as accurate and as uniform as possible. To further safeguard reliability, a lid with a tight seal should be kept on the solvent at all times. You may make the solvent in any size batch you wish, as long as the ratio of chloroform to isopropanol to acetic acid to deionized water is correct. After mixing these ingredients vigorously, allow the solvent to stand 15 to 20 minutes in the development tank. Mark the starting line for your sample 1 or 2 centimeters from the bottom of the TLC slide. As shown here, a piece of cardboard with a straight edge provides a convenient start line. A worksheet provided in the manual that accompanies this video can be used as a pattern for placement, labeling, and measuring of samples. Use microcapillary pipettes or a common syringe to spot the plate at the start line with your test sample solutions and allow the plate to dry. A known standard sample of bear bile acids should be spotted on the same plate so that you can easily compare the profiles of the unknown biles against those of the known bear bile acids. It is important to concentrate each spot by repeated applications of each solution at its location on the TLC plate. Be certain to dry each spot under a hairdryer between applications. Once the plate has cooled completely, it is ready to be placed in the development tank. The solvent depth must be shallow enough that the spots along the start line are above the solvent when they are first placed in the development tank. Allow the solvent to climb up the plate to a height of between 15 and 17 centimeters, which will take approximately 2 hours' time. Do not expect to see the separation of bile components on the plate at this stage of the test. Once the solvent has reached its destination, remove the plate from the development tank and dry it under the hairdryer until all residual solvent has evaporated. Once the plate is completely dry and cooled, It should be placed back in the solvent for a second development. This second process will concentrate the separated bile components for more pronounced results. Again, do not expect to see any results on the plate during this part of the process. There are two additional solutions necessary for the final development of your sample results. These are called reagent sprays. The first is a mixture of sulfuric acid and water.
In preparing a 20% solution of sulfuric acid, precautions should be taken when preparing any acid solution. You should always add the acid to the water to prevent any sort of splattering effect. So I'm adding 80 ml of water to the flask. And now I'll be adding the sulfuric acid to the water. Glasses should be worn to avoid any sort of splattering that could affect the eyes. And using a ventilation hood that you can also pull down, also as an extra precaution. Add the sulfuric acid slowly and be careful not to handle the container because the mixture will begin to warm up and may become hot. Gloves also should be worn to avoid any dermal contact with the acid.
One chemist described sulfuric acid as more dangerous than a charging rhinoceros. This cautionary note is meant only to urge very slow and careful mixing of the acid in cold water. To make the second solution, you simply stir the proper amount of phosphomolybdic acid into isopropanol.
Okay, I'm preparing a 3.5% phosphomolybdic acid solution using an analytical balance to weigh out 3.5 grams of phosphomolybdic acid. First zero the weigh boat and then weigh out the 3.5 grams of phosphomolybdic acid. For the 3.5 grams of phosphomolybdic acid into a 125 ml flask, and add 100 ml of isopropanol. Allow the phosphomolybdic acid solution to mix for up to an hour.
After 2 hours, again remove the plate from the solvent. Once completely dried and cooled, spray the plate with the sulfuric acid solution, and then with the phosphomolybdic acid solution. You may use a scientific sprayer, as seen here, or a canned aerosol propellant to create a fine mist. You may also wish to place the plate in a cardboard box to contain the mist as much as possible. A ventilation hood is strongly recommended, as sulfuric acid fumes can be very harmful to eyes and lungs. Place the sprayed TLC plate on a preheated hot plate or in an oven pre-warmed to 100 degrees Celsius. The heat will interact with the reagent sprays and the spotting on the plate to create a visual image of your results. When using a hot plate, move the TLC plate around periodically for a more even distribution of heat. Avoid overheating glass plates as they may shatter. Heat the TLC plate for approximately 5 minutes or until blue spots appear. These spots are the profiles of your bile samples and standards. Carefully remove the plate from the oven to avoid cracking. Once the plate is cooled, it is ready to be read.
And I'm going to draw a line for that spotting line. Then I'm going to document the spots for hard copy by drawing them in on the log sheet at the appropriate distance. This is the known Bayer gallbladder standard, in which you can see the 3 bile acids that are present. This is torcolic, torquino, and torurso. We can determine that because we have pure standards of those 3 bile acids. This is the torquino, which lines up with torquino. This is torcolic, pure standard, which lines up with torcolic. And the pure standard torurso lines up with torurso. Here we have another Bayer sample that also has the 3 bile acids.
Scientists at the National Fish and Wildlife Forensics Laboratory have never had false negative or false positive results from this method when testing for bear bile. To avoid overhandling the plate, you may wish to make a photocopy of it. Using the worksheet at this stage will simplify analysis of your results. Place the worksheet atop the plate before photocopying, as shown here. There is one more variable that you should be aware of when analyzing your results. Bears are now farmed for their bile in China, South Korea, and North Korea. Bile liquid is extracted from farmed bears through a tube surgically implanted in their gallbladders. Chemists at the National Fish and Wildlife Forensics Lab have been conducting tests of bile obtained from bear farms in China and have seen in preliminary findings that the farmed bile seems to contain very little torocolic acid.
So this is torcolic acid here, and on the top is torurso deoxycholic acid. This is torquino deoxycholic acid. These two typically are always present, but what we're seeing in suspected farmed bear bile, a lack of torcolic. But in using thin layer chromatography, since it is more sensitive, it will pick up even small quantities of torcolic acid.
When your samples show concentrations of torurso and torquino, but little or no torocolic acid, you can infer that these bile acids have come from farmed bears. If, however, the bile samples you are testing have come from a pig, for example, the TLC profile would have looked like this. Notice that the profile of the glycinated acids in pig bile left a concentration of spots far above those typical of bear bile. The taurinated bile acids, characteristic of bears, always stay toward the bottom of the TLC plates. While TLC is a highly accurate test, it is presumptive rather than definitive. That means TLC will give you sufficient evidence to prosecute a suspect for violating laws restricting the sale of bear gallbladders.
After performing the analysis on thin layer chromatography, if you receive results such as this, where you have spots at the torcolic area, at the torquino deoxycholic area, and at torurso deoxycholic, you can be pretty certain that you have samples that are from the bear family. In order to prove that beyond a shadow of a doubt that it is actually from the bear family, you would probably want to send it to a lab that could perform HPLC, or a high-pressure liquid chromatography, in order to confirm your analysis by thin layer chromatography.
Instructions for sending evidence to a forensics lab are included in the accompanying manual. Please be sure to refer to the manual for precise instructions regarding the simple chemical procedure you have just seen. If you have any questions or problems regarding the use of this method, please write, fax, or telephone the individuals and agencies listed at the back of the manual. From time to time, we will be in contact with you to inquire about your use of this test as a tool for policing the trade in bear gallbladders. Thank you for your time.